Good evening, everyone. I am Vatsal Dharmesh Kumar Patel, a research scholar from the Department of Civil Engineering, Indian Institute of Technology, Guwahati, India. I will present an article titled Mass Balance Assessment of Jammu Glacier and ELA-AAR based approach. And this study primarily focuses on the Jammu Glacier as it is the largest glacier in the eastern Himalayas located in the Sikkim state of India with an area of around 80 square kilometers. Also, the Tista River receives a major contribution of discharge from the Zemu Glacier. Tista is also called the lifeline of Sikkim and has many power plants which have been constructed on this river. Therefore, the monitoring of Zemu Glacier is important. But monitoring of glacier becomes difficult due to lack of connectivity and the harsh terrain of the Himalayas. Also, being a summer accumulating type glacier, a cloud cover and the frequent snowfall during the ablation period becomes a major obstacle in accurate mapping of its accumulation area for the remote sensing based study. Therefore, this study aims to constitute an approach to overcome the limitations of mapping the accumulation area by developing a relationship between the equilibrium line altitude and the specific mass balance of the Zemu glacier. The datasets used for the present study are Random Glacial Inventory for the glacial boundary extraction, LOS-DEM for control line extraction and the generation of hypsometric curve, and Sentinel-2 imagery for the mapping of the glacier. Here, the AAR was estimated manually through the manual delineation and also by using the hypsometric curve and ELA. So after following these particular steps, these are the outputs which are obtained through this methodology. So these are the equations used in this study. First is of NDSI for the mapping of the accumulation area. The second one is the empirical relationship showing the relation between the AAR and the specific mass balance for the central and eastern Himalayan glaciers, which is established using the field data of some of the glaciers from the central and eastern Himalayas. And the last equation, which represents the empirical relationship between the equilibrium line altitude and the specific mass balance. Now coming to the result section, this is the hypsometric curve of the Zemu glacier derived using LSDEM, which shows the relation between the glacier surface with respect to the elevation. This figure shows the chronology of steps performed in the methodology. Part A shows the false color composite image of Zemu glacier. Part B shows the NDSI image. Part C shows the image after application of NDSI threshold. And Part D is the important one. It shows the classified image of Zemu glacier into the ablation zone and accumulation zone. Also, we have found that the average elevation of the fun line in the four segments of the Zemu glacier can be considered as ELA. Therefore, even if the glacier is partially covered with clouds, the available segments can be used for the approximation of the ELA. As mentioned earlier, the accumulation area ratio was derived using two methods. The accumulation area ratio derived using hypsometric curve and ELA shows a good correlation with the manually delineated AAR as shown in this figure. And this table shows the value of specific mass balance obtained using AAR for the period of 2016 to 2020. The specific mass balance was found to be least for the year 2019, and in terms of month, the month of August shows the least accumulation area ratio as compared to the other months of the ablation season. The balance by the TLA, that is the ALA at an instant where the specific mass balance of the glacier is equal to 0, was found to be 498 meter above sea level for the Zemu glacier, and the regression relation can be described by this equation of between the ELA and the specific mass balance for the Zemu glacier, with the empirical factor equal to minus 0.0011. ELA and the specific mass balance by this method was calculated for the Zemu glacier for the period of 2021, and by the result obtained, we can conclude that the average elevation of the fun line of the selected segment of the glacier provides a good approximation of the accumulation area, and The regression relationship developed between the EL and specific mass balance enables us to approximate the specific mass balance of the Zemu glacier even if it is partially covered with clouds. So these are selected references. Thank you.